Hello students, welcome to Arjun English School. This is for 11th class statistics subject, chapter number 5, skewness of frequency distribution. Okay, it is completely based on chapter number 3 and chapter number 4. If you learn that chapter properly, then this chapter will be helpful because it is the revision of chapter 3 and 4. Okay, so first of all, my question is the what is the skewness? So skewness, it is the frequency distribution with lack of symmetry is called skewness frequency distribution. Thus, lack of symmetry, it is called skewness. Now, what is symmetry? To understand the symmetry, there is another definition for symmetric frequency distribution. Here, a frequency distribution in which observations of the populations are evenly distributed on both the side of mode, which is called frequency distribution, and its frequency curve, it is called symmetric frequency curve. Means all the observations are of frequency are distributed on both the side. Means here if it is zero, then some observations of the population are on negative side, some populations of the observations are on positive side. So we can call it as a evenly distributed on both the side. Okay, it is the neutral point. So now it is this curve, it is called frequency distribution. What is the curve? Curve is like this, it is a bell shape. Got it? So this is called bell shaped curve, and this curve that we call symmetric frequency distribution, where all the observations of populations that are distributed evenly in both the sides. Okay, generally the frequency curve of symmetric distribution is found to be bell shaped, that you can see. Got it? So this is called symmetric frequency distribution. And now our next topic, that is, yes, frequency distribution with lack of symmetry, it is called skewed frequency distribution. Lack of symmetry means कि this curve is not exactly evenly distributed between the both the side. Okay, this is called symmetric. But here the lack of symmetry, it is called skewness. Like if it is completely down to the left, then right, or it down to the right, like this. So here are the examples of skewness. Means all the observations are not evenly distributed, that is called lack of symmetry, and it is called symmetric frequency distribution, and the lack of symmetry that we call skewness. Simple. So there are some situations of skewness where value of mean, median and mode are not same. Second, quartiles of Q1 and Q3 are not equal from median. Third, right or left side of frequency is more elongated. Fourth, frequency of observations at equal distribution of both side of mode is not equally distributed. That I have prepared a graph over here. at one time it is elongated at left side, and in another graph you can see that it is elongated at right side. Elongated means it is straighted to left or straighted to right side. Now next point is types of skewness. There are two types of skewness. Number one, that is positive skewness. Second one, it is negative skewness. Now, in positive skewness, right tail of frequency curve distribution is more elongated. Then it is called positive skewness. Okay. Here it is a graph for right elongated, that is we call positive skewness. Okay. So here you can see clearly that it is more straighted to right hand side. Clear? Once again, we already studied the central tendency and then after dispersion. Now in skewness, all the observations of populations are not clearly evenly scattered on the diagram, but these diagrams are elongated either on left side or right side. So due to this, skewness arises. And now there are two types of skewness, positive as well as negative. So here it is more elongated to right hand side. So we called it as a positive skewness. And next one, negative skewness. Yes, this one. In negative skewness, it is left tail of frequency is more elongated. So it is called negative skewed distribution. Clear? In this diagram, I want to clarify here. So here you can see that it is more elongated to left hand side. So it is called negative skewness. Got it? Now, so here there are two methods for determining skewness and coefficient of skewness. It is the most important, where the name of these two methods, Karl-Pearson method and Bowley's method. Got it? It is most important method, Karl-Pearson and Bowley. In practical aspect, we have to calculate these sums on both the aspect, and if no information is given, simply they just told to calculate the skewness, but the method of skewness that not clarified. So in this situation, we have to use Karl-Pearson method. Simple. So now here it is a method of Karl-Pearson. The value of mean, median and mode are not same in skewed distribution, and the median is between mean and mode. It means mean, median and mode are not same at this point. So now here the meaning of skewness, that is x bar minus mo. This is the first formula under Karl-Pearson method. Skewness is equals to x bar minus mo. X bar stands for mean and mo stands for mode. Now it is the skewness. Another point is coefficient of skewness. Another point is coefficient of skewness. Coefficient of skewness that we call J. small j. Small j stands for coefficient of skewness. Formula is x bar minus mo divided by s. Again, x bar stands for mean, mode, and s stands for standard deviation. Got it? Now, there are some situations where mode cannot be directly find out. In such a situation, we have to use the empirical formula. Empirical formula, that is MO is equals to 3m minus 2x bar. Simple. Here it is the formula. This one. This is called empirical formula. MO is equals to 3m minus 2x bar. This formula that we have already studied in chapter number 3. Okay. So now there is another formula for skewness. When mode cannot be find out clearly, then another formula for skewness, Sk is equals to 3x bar minus m. Here m stands for median. So if we cannot find this skewness by using mode, then there is another option to find skewness by using median. So skewness is equals to 3 in bracket x bar minus m. And another formula for coefficient of skewness, that is all these are remain same, 3 in bracket x bar minus m divided by s. S stands for standard deviation. Okay. So in Karl-Pearson method, there are two formulas to calculate the skewness and coefficient. Number one, if we can use the formula for mode, then formula is x bar minus mo, and j is equals to x bar minus mo divided by s. But if mode cannot be find out, then we have to use the formula for median, where formula for median skewness is equals to 3 x bar minus m and j is equals to 3 x bar minus m divided by s. Simple. So this is called Karl-Pearson method. Clear? Now you can see that formula is very simple. Either we use the mode or we use the median. But the problem is, what the possibilities if all the values are not given directly? Then first of all we have to find out x bar, then mo, s, or we have to use instead of mo there is m, that is mean, mode, standard deviation, and median. So x bar, mo, and m are the part of chapter number 3, and s is the part of chapter number 4. So as I earlier said, that this is the simple revision of chapter number 3 and 4. So first of all, go to chapter 3 and 4, study all the formulas, get the clarity on all the formulas, and then after start this chapter first. Okay. So now on the basis of this, I am starting a practical examples on the basis of Karl-Pearson method, but it is in the next class. So now today's session is over. See you in the next class with the practical formula for Karl-Pearson method. Okay. Thank you.